Hi, this is Samil Bharti, and we are here in Washington, D.C. And today we have with us Alexander Gounares. You are CEO and founder of a company called Polyverse. And the story of the company is really interesting. The work that you're doing in the security space is kind of, because the way you're approaching security is a bit different. So before we get into the work that you are doing, I'm just curious to know that at what point and what problem you saw in the market that you wanted to solve, that you created Polyverse.
Yeah,
and what is the story behind the name Polyverse?
So first off, Swapna, thank you very much for hosting me. Delighted to be here. Delighted to be on the program. I'm a big fan. So in terms of how we got started, in my previous career, I was CTO for Microsoft Online, now CTO for AOL. Our co-founders had big roles at Amazon, running site reliability at Amazon, for example, and our head of engineering used to run a lot of the infrastructure in Microsoft Azure. So all of us sort of came from this background of running large-scale, serious internet systems. And one of the consequences of running a large-scale internet service is that you're constantly under cyber attack. The bragging rights for a hacker to take down Microsoft would be quite high. And so you're just constantly getting these attacks. And very bluntly, as just sort of practicing engineers in the field, we were very frustrated with the available solutions. If you look at the cybersecurity market today, nearly everything out there is some form of reactive solution. Right? There's a lot of great technologies, a lot of fancy innovation with AI and machine learning and so forth, but fundamentally they all take attacks and then say after the fact, after the attack has happened, say, oh, by the way, the horses have left the barn. And there's value in that. It's valuable to know that you've been it's valuable to know that you've been attacked, valuable to know some of the forensics around it. So we're not saying those aren't worthwhile products, but what if you could not be hacked in the first place? If you're Equifax, I'm sure they, one hand is great that they were able to detect the attack, but gosh, what if you could have stopped those 4 Chinese, since there was just recently the announcement of the indictment against these 4 Chinese who were responsible for the Equifax hack. What if you could have just stopped them from getting in the first place? And that really became the motivation for Polyverse, was to say, how do we fundamentally solve this? And in my background, I was very familiar with a technology called moving target defense. And it's this idea of creating diversity in the environment. If you think about computers today, every software system has bugs. Alan Turing proved this with the halting problem, right? You say anything that's non-trivial is just going to have bugs. So if you have a bug, then it might be hard, but at some point an adversary is going to figure out how to exploit that bug and take over your system. Right? It just sort of goes hand in hand. If you have bugs in systems, there will be some kind of exploit. So that's almost mathematically provable. So it'd be very, very hard to get rid of all of the vulnerabilities. Like if we knew how to fix every bug in software, we'd be having this conversation in Bora Bora and I would own the place, right? But we don't know how to fix all the bugs in software. So if we can't do that, then can we look at the other side of the coin, and that's the payoff on the attack. Today, it might take me months or years or millions of dollars to figure out how to actually exploit a bug. But if I do figure out how to hack a system, I'll get every version of it because everything is a clone. If I learn how to hack Windows, I'm going to take over 1 billion computers. And we see this with things like the WannaCry hack that just go take over scores of systems just seemingly overnight because they're all clones of each other. And so the sort of idea that's been around of moving target defense for almost 30 years now said, well, what if we created diversity in the environment? If you sort of think about it in a very simple way, Macs don't get Windows viruses, and Windows don't get Mac viruses, just as a general rule of thumb. And the reason is if I'm a cyber attacker, I need to know what it is that I'm attacking. I need to know that it's a Windows computer or a Linux computer or something like that. 'Cause I need to know those technical details. And what happens if I don't know, right? What happens if we make every computer unique? And that's been the concept of moving target defense. And then sort of coming back to the original question of how we got started, in 2015, my co-founders and I realized that actually this old idea that people had of, gosh, what if we could make everything unique? We realized that that was, in 2015, extremely practical. And now by 2020, we're running on millions of servers. We have 20,000 servers alone in our build farm that we run completely lights out, hands-free operations. So we're doing this at massive scale. So this old sort of academic idea, we were able to figure out how to do it at scale with a one-click fire and forget install.
So the basic concept, as you mentioned, moving target. So is this a unique approach, or is it something which is common in the security or defense industry? At the same time, how do you really, there are billions of computers. How will you, I don't want to get too much into detail of the technology itself, but and I'm pretty sure that it's not as complicated as it sounds like. It should be something easier. That's why you can implement it throughout that. So what is that model that every system has something unique print into it, which makes it hard for an attacker?
Yeah. So if you look at the different attacks, and Equifax is a good example. The attackers came in and took over the web servers, but they understood how the web server worked because that's just all open source, and they were able to then go inspect, and they understand how HTTP works, they understand the programming language, and they were able to go in and say, we know where the data is for somebody's social security number, their name, and so forth. It's because all that was basically visible to them. And so when and in cybersecurity parlance, it's known as the reconnaissance step. You go learn what your target has, and once you learn it, you're able to craft the attack. And what we're doing is literally using a technology called polymorphism. We're literally changing around the script engines, changing around the binaries, so that it's not anything that an attacker can discover from the outside.
Can you define the term polymorphing? What's that?
Polymorphism, yeah, that's a technical term, and what it means is to create multiple versions of the same thing. So this is actually inspired by biology. All of us, you and I are both humans. Everybody listening is humans. I would assume you might have some bots in there, but but all of us, listening in, we're all humans. So we all serve the function of human, running the program human, but all of us have different DNA, right? We're all unique on the inside. So humans are polymorphic in that sense, right? We all sort of function the same, but with sort of different internals. And that's exactly what we do with the software, is we literally change around the assembly code, the script engines, things like that.
But we still get common flus or coronavirus, which is spreading. There's a lot of common things that can affect humans. So it's
common. But if you look, I don't want to downplay the potential seriousness of the coronavirus. But if that were a computer virus, it would have wiped us all out already. Because you sort of think about it, the number of people is impacted versus the 6+ billion people in the world, right? So as a species, our diversity gives us a lot of resilience. Mm-hmm. Now you think about human diversity, you actually get into the DNA, and this is where the coronavirus, it's about 2%, if I recall the numbers. I'm sure there might be a biologist mm-hmm. on your watching this who says, oh, it's not 2%, it's 2 point whatever. But, on that order, the amount of diversity in sort of human DNA is actually, relatively speaking, low, which is why viruses are able to impact subsets of the population. And what we're able to do is literally get 100% diversity.
Right.
We're able to change literally every byte on the machine, such that there are literally quadrillions of different permutations.
And going back to the point of diversity, which is like kind of not that critical, but the same carrier may have come across 20 different people, but only 2 got infected, you know.
Right.
Yeah. So yeah, your point is valid there. Now going back to you mentioned Equifax.
Yeah, and those 2 people had similar DNA. But if they had absolutely different DNA, then they probably wouldn't have gotten infected.
Right. Let's go back to the Equifax, because that was a kind of case which was where the company was responsible. The patches you mentioned, that was open source code. The patches were there, they were just did not implement that. So there are a couple of things there. First of all, is that in traditionally, security is often seen as an afterthought by developers. They don't start their software with security in mind. That becomes that's not their problem, that's someone else's problem. But then DevSecOps, some new paradigms are evolving. Plus, we have moved to cloud native world, where everything is, that's why we are talking zero trust. You cannot trust anything. At the same time, things are modular or, microservices. They're not monoliths that you have to move a big giant code base. You can implement security features very quickly.
That's right.
So as the whole paradigm is shifting, software development model is shifting, evolution of DevSecOps. So if you look at the old school of, security is an afterthought, or, companies like Equifax don't even bother to patch when the patch is already there, versus the new model where they're moving very fast, so it doesn't really matter, you can implement it. How does it changes it for Polyverse? Because sometimes it is seen as a technological problem, but at times it's seen as a cultural problem. Yeah. So how do you see this change?
So let me start with the cultural aspect at first. And Equifax is a great example. Look, since probably most of us were impacted by Equifax, it's easy to sort of pick at them and say, oh, shame on you, you did a bad job, you should have patched more quickly. But when's the last time you drove a car and you had to worry about the pressure on your brake lines or the timing on your spark plugs, right? You're able to drive a car safely and know that the brakes are going to work without being a hydraulics engineer, right? And so when you think about Equifax, their business isn't cybersecurity, right? Why are we expecting them to be on top of all the latest stuff, right? It's sort of an unreasonable cultural expectation. What we need to do as an industry is be more like the car industry, where we just make stuff that just works in the first place, right? And doesn't need a lot of hand-holding by experts. Because when you dig into this patch problem, yes, Equifax didn't patch rapidly enough. That's pretty well established. Who can? If you look at some of the reports from CrowdStrike and others, once a patch comes out, you have about 20 minutes before the hackers have engineered malware against it. Okay, I don't care how good you are.
Right.
Nobody can patch a substantial fleet in 20 minutes. Which is not going to happen.
Very valid point, yeah.
And so, let's say now that you magically could. Let's say you're just amazing and you could patch everything in 1 minute, just instantaneously. The patch comes out, doesn't stop you from the 0 days. That Equifax bug existed for over 6 months before the patch came out. Right. The WannaCry bug existed for 10 years. Right? The Bluekeep bug existed for I forgot how many years. If you go to the polyverse.com website, we actually show you a static code analysis of Linux. There are over 1 million unpatched buffer overflow bugs in Linux today.
Right. I mean, Linus once said,
and not like Windows is any different.
No, right? Bugs are part of software development process. As long as you're creating software, there will be bugs. So and that brings to the point that if we don't expect it from company like Equifax, just like car manufacturer, it should just work. So who is the player that ensures, because even when you talk about car manufacturers, they have a lot of partners. Everybody is doing playing a different role in the assembly line.
Yes, this is where I would say the software industry should bear the responsibility of saying, let's up our game, because we have the technology with moving target defense and polymorphic technologies we have the ability to stop cyber attacks, large classes of them, right? The stuff that's going on in the world, we know how to stop, right? So the Polyverse technology would have stopped the Equifax attack had it been deployed there, for example.
So let's just look at the analogy of car industry. So they have the whole supply chain. So if you look at the software supply chain, so Equifax, okay, they're also distributing software which their companies users are using, but they have a long supply chain of they are using different components that are coming from either open source projects or they are building it in-house. So you are also part of. So the way I look at it is that security is a part of the whole supply chain.
That's right. Absolutely, totally agree. Right, and so it's those vendors that are part of the supply chain that really need to focus on not security as an afterthought as you were describing, but building it in from the get-go.
What changes are you seeing in the market as more and more companies are relying on not only software? Equifax was just financial data, which is critical, but now we are putting our lives at stake when you're driving self-driving cars like Uber. Of course they're also getting into self-driving car, Tesla, like that. How critical it is becoming, and how seriously companies are taking security, because a small breach can be like. Yeah. So what role can you play in there?
So a couple of great questions in there. Maybe I'll start with the role that we play. Since we're focused on fundamentally stopping attacks, any company that is really focused on fundamentally solving it and prioritizing cybersecurity, becomes a great partner or customer of ours. And what we're seeing I would say broadly in the industry, is an increased focus on secure by default. Right. In fact, that's why I'm out here in DC, because we see this, for example, in the military. There's a new program called CMCC, where they're now requiring their entire supply chain to be cyber secure. And it's sort of, it's not a complete be-all, end-all of everything, but it's an amazing first step, because now they're saying everybody must attest to their cybersecurity as part of selling to the government. And that's a huge change from before. On the flip side, we still see a lot of compliance mindset. I won't name any names because I don't want to pick on anybody in particular, but there are quite a number of folks who are nominally in the security industry. There'll be a CISO or whatnot at a big company. And what they're focused on is compliance, whether it's PCI, HIPAA, some of the Sarbanes-Oxley requirements or what have you. They'll just sort of go through and say, well, I'm supposed to have a firewall, I'm supposed to have an antivirus. What's the cheapest vendor I can get? Let me check the box and say, yep, I ran my compliance program. And just buying a firewall and antivirus really doesn't do anything for security against any sophisticated adversary. They're useful to have, and those products provide value, but they're not going to stop a sophisticated adversary. And so we still do see a lot of compliance-focused mindset in the market.
And as you were talking about your presence here in the DC, so are you working on some programs with the government, or you're exploring? Can you talk a bit about the work that you're doing?
I can't talk a lot about it, but we are. We do work a lot with the government and commercial companies. We're primarily a commercial company, so across the millions of servers we're deployed on, that's vast majority of that are commercial. But if you think about the DoD in particular, they're kind of the pointy end of the spear with cyber issues. Cyber has become essentially a fourth element of warfare these days. So you think about World War I was kind of the introduction of air power, and it really came to bear in World War II, where carriers and all that just really shifted the balance of power in fighting. These days, it's cyber attacks, right? And if you look at what happened in the Ukraine with Russia, I'll oversimplify a little bit because there's a lot of complexity to the events going on there. But one of the elements of the fighting there was a cyber attack against the Ukrainian power plants. And so now we're seeing for the first time in history, and like actual, like real live fighting as part of military, you've got to worry about your troops on the ground, your air power, your sea power, but now you also use cyber power to go cripple your adversary before sending in the troops. And that's being done for real, these days. And so it's a vital part of any military strategy, both the defense and the offensive side.
This may not be relevant to this discussion, but if we look at the whole discussion on Huawei and a lot of Chinese manufacturers, they might have backdoors. If you look at, my phone is literally made in China. Most of the networks all the DJI drones, they're made there, so they might have hardware. How critical is that? Because you literally have hardware sitting in here, which might have hardware or backdoors. So how is the government looking at them, and what can Polyverse do there?
So there are, this is a fairly deep and layered problem. So it's absolutely possible to do supply chain attacks into the hardware and try to get your malicious hardware inserted. And the more you're working with diligent and scrupulous vendors like Apple, I think does a pretty good job. Can I, as an outsider, guarantee that Apple will never have an issue? Of course not. But knowing what I know about Apple, can I say they do a pretty good job of trying to keep integrity of their designs from what was designed to what was manufactured to what actually shipped, and that it is what they thought it was going to be, and that phone just had the parts they wanted and not a hacker's parts. Yeah, they do a pretty decent job. And so that's sort of one hard problem. And then on the software side is where Polyverse comes in, where one of the technologies we have is something called a build farm that gives our customers complete end-to-end integrity over their software stack, from the software all the way to the deployed bits. And that's a huge advance over kind of today's world, where one of the beauties of open source is you have millions of people contributing to this around the world. There are literally over 8 billion lines of open source code out there. Just a fabulous ecosystem. On the flip side, where's your stuff coming from? And if you're just using the standard open source tools, you're pulling down code from, frankly, you don't know where, right? And so you don't have a lot of confidence or integrity in that supply chain in the standard models. And so what we've been able to do with our Build Farm product is, for those high-end customers that really need that supply chain integrity, where they know exactly where it came from and how it got transformed every step of the way, we give them that control and visibility, to the entire OS, from the kernel to the drivers to the apps and everything.
One question you dodged was the name of the company.
Yeah, I didn't mean to dodge it.
You're in DC. You mastered the art of dodging questions that you don't want to answer.
That's right. I'm still an engineer, so I'm not good at that. So the name of the company came about actually right when we got started, and it was sort of suggested by our lead investor of all people. And obviously, first off, naming companies is impossibly hard these days, because particularly if you want the domain name as well. But what a polyverse is a multiverse of multiverses. So if you know what a multiverse is, sort of a consequence of quantum mechanics. It's this idea that says for every action, there's another parallel universe created. So, there's a universe in which I didn't dodge your question.
Yeah, if you have seen Endgame, already know what is multi. If you have any Marvel movies from Ant-Man,
Exactly, yeah. If you've seen any Marvel movies, you know the multiverse. So a polyverse, but the thing with multiverses is, by and large, the physics in every universe is the same. And a polyverse is a multiverse of multiverses, where the physics can be different in every multiverse.
So the me there is not the identical me.
Exactly, and maybe maybe you're 10 times bigger or 3 times smaller just because the gravitational constant is different, right? Or maybe there is no gravity. Maybe it's something different altogether. And so if the physics is different, then sort of the rules of how the system works are going to be different. And so when we saw that name, we said, okay, this is the perfect name for our company, because Polyverse is about creating that that diversity, that difference in rules, so that there's enough entropy in the system that it becomes uneconomic to do the hacks.
Awesome, that's an excellent. I hope Marvel will come up with a movie also.
Yeah. Well, we'll license the rights to Marvel. Just to be clear, we do own that one, so we'll have to license it.
Anything else, or do you think?
Yeah, maybe the thing I'd love to end with is just for everybody listening in on this. First, thank you very much. I hope you found it interesting. But I would ask that you go back and look at your DevOps process, your DevSecOps process, and just ask a very simple question. Where are you getting your Linux from? I don't care whether it's Ubuntu, Red Hat, CentOS, Fedora, Debian. There's a lot of great Linux distributions out there. But right now, if you're pulling down a standard open source Linux, you're getting the same Linux the hackers have. And like I said, there's millions of bugs in that. There's lots of bugs in Windows. Nothing's immune from bugs. But do you want to run the exact same binaries that the hackers are analyzing and figure out their exploits for? Or do you want to run something different, unique to you? So don't run the same code the hackers have. That's kind of my punchline and my ask. And we'd be happy to obviously give you different code, but since it's all open source, you can do it yourself too. But just whatever you do, be different than the attackers. Don't be a sitting duck.
If somebody wants to check out or try out or see, what is your pricing model? Do you also offer some trial versions? How does that work?
Free trials. Just go to polyverse.com. There's free demos on the web. There's a free trial, and we have pricing for small businesses to very large enterprises.
Awesome. So, thank you, Alex, so much for taking your time out and talking to me. And I look forward to seeing you again.
Same here.